So welcome to this Nordic Partner webinar. Today with us we have Quuppa. This is a company delivering real-time locating systems. And they are pioneers in direction finding and using the angle of arrival technology in very advanced ways. And they have a system that fits many different use cases. So my name is Petter Myhre, and I work as a product marketing manager for Nordic. But today it's not going to be about me, it's going to be about Quuppa. And we have quite a few guys from Quuppa with us today. So welcome Quuppa. Maybe you can say a few words about yourself.
Thank you, Petter. Yeah, I can start. So I'm Fabio Belloni. I'm one of the co-founder of Quuppa, Chief Customer Officer, and I lead the team that provides support to our customer globally. Nice to meet you all.
All right. My name is Santtu Pulli, and I'm leading the tag ecosystem here at Quuppa. And very, very nice to have you guys all online right now.
Hi there, I'm Thomas Hasselman. I'm the Chief Marketing Officer at Quuppa, which in practice means heading the sales and marketing.
Thank you, guys. Then over to some practicalities. So the duration of this webinar will be approximately 50 to 60 minutes. Might go a few minutes over, but we'll try to keep inside the 60-minute limit. Questions are encouraged. Please use the ask your questions in the top right where it says ask question. All questions are anonymous, and please try to keep them relevant to the topic. We will answer the questions towards the end. Then I would also like to say that the chat in the bottom left is not anonymous, and please do not use this for questions. Please use the ask question tab to ask your questions there, and we will take them in the end. And if you have more questions or your question didn't get an answer, you can always go to DevZone for Nordic related questions, or you can go to contact Quuppa at the web address on the slide here. And as always, I will put a recording of the webinar together with the presentation at the webinars.nordicsemi.com probably tomorrow. Then it's over to you, Fabio.
So it's our pleasure to be here, and thanks for everybody for your time to joining this webinar. So let me start by telling you something about Quuppa. So Quuppa is a company, is a spin-off of Nokia. We have started Quuppa back in 2012. Before that, myself and the other founders of the company, we were working at Nokia Research Center. Our team was focused and dedicated on indoor location and local connectivity. And we have been doing location technology since the early 2000s, trying different flavors of positioning in connection to mobile devices. After Quuppa was founded in 2012, we focused more and more into productizing, direction finding, and build a platform that would be able to provide coordinates to our partners and companies that are interested to build a solution for location-based services. Quuppa is headquartered in Finland. We have offices with full-time personnel spread around the globe. Currently, we have more than 550 customers. So customers for us are companies, typically system integrators, solution providers, service providers. But among these 550 companies, 170 of them, it's what we call Quuppa partners. And these are companies that we do repetitive business with. We have a frame agreement, and we have a way for them to resell our platform and technology into their market, either vertical markets or geographical markets. We currently have more than 2,000 deployments in 55 countries. And in here in the bottom, you see some of our key achievements for 2019. Personally, one of the one that I like the most, since I like sport, is the ice hockey. So we are the official supplier of technology together with our partner Bitwise, and we have more than 50 arenas currently deployed, and every single official Prime League game is played and tracked by Quuppa technology. So let's first answer and look into the Bluetooth standard. This is typically a question that comes out a lot. So Quuppa has been involved into the standardization since the very early days. Well, at that time we were not Quuppa, we were Nokia, and our team, as Nokia, was responsible to start in the standardization back in 2010. Our CTO wrote the first version of the direction finding specification, and then after that, that became effectively the BTSIG direction finding working group. We are very excited that after many years, and we want to thank everybody that during the years have been contributing to this standard. In 2019, the 5.1 or Bluetooth direction finding finally came to the market. And we as Quuppa are extremely happy for that. We are embracing and trying to leverage on the standardization. And if you want to read more, there is here in the bottom of this page a link to that article. But just to clarify, where does Quuppa stand in the Bluetooth direction finding value chain? This is a very simplified sketch showing that on the left-hand side there is the BTSIG, which effectively provides the standard and standardization specification for all the different technology. Then there are silicon vendor, like here our partner Nordic. They take the specification and they build upon the specification their silicon. And Quuppa practically uses the standard Bluetooth radios. This is something to be maybe clarified. Quuppa is not providing proprietary radio solution. We are not a silicon vendor. We always use standard BLE radios. And we take the standard BLE radios, and by doing some firmware modification on those radios, so running effectively our Quuppa profiles, or by building the entire hardware, whether it's a tag or is a locator, and of course, most importantly, having our software tools. So we have many tools that allow testing, planning, commissioning, deploying the entire positioning platform, and our Quuppa positioning engine is the brain of the system. So that's practically what makes the Bluetooth direction finding really be able to produce reliable, accurate, and low latency location tracking information. And then our interface towards our customers, which are system integrator and solution provider, is through a software API. So that company can build their own services, their own application. We effectively are providing the dot on the map, and then those companies really get creative to build their services and application. And these services and application are typically then flipped and provided into the market, the different vertical markets, depending on also the geographical area. So this is where Quuppa sits, and this is why we are extremely happy to cooperate with Nordic, and how do we partner with silicon vendor towards providing Bluetooth direction finding into the market. Just to give you a sketch on the Quuppa architecture. So everything that you see on the violet background is effectively Quuppa. System is the core Quuppa offering. We have locators, which are the hardware components that are mounted in the infrastructure. We have both indoor and outdoor models. This picture shows the LD7L, the square device that goes typically outdoor. And then we have the Q17, which is the newest indoor locator. We have other models in the roadmap, so keep tuned, and you will see what we are going to launch later this year. And then all the hardware connects to our positioning engine, which is the brain of the system. The hardware itself doesn't do much. Besides collecting the data that comes from their interface and sending the raw information to the positioning engine. The positioning engine can run on cloud, can run on-prem, depends on the system integrator preferences. And then we have a software API which flips to the application layers that are typically built by our partner. So as you can see on the right-hand side, we have the software integration interface towards the Quuppa system, and on the left-hand side, towards the tag, that's where we have our hardware interface, and that's what my colleague Santu will discuss more later in the webinar. We can track tags, we can track phones that are running up, and they are emulating a Bluetooth direction finding packet. We can also absorb data coming from devices like the Polar H7 for effectively IoT remote sensing. The Quuppa technology is primarily based on the methodology of using direction finding. We don't really make direct use of the RSSI or the power of the signal. For us, that is a secondary component that we can use, but otherwise everything is based on measuring the phase of the signal that comes to the locator, and ergo translate that into angles and furthermore in position. So this is why the Bluetooth based technology that we are using can be extremely accurate, because we are able to measure for every radio packet transmitted by a tag of a phone, both the azimuth and the elevation angles, and that can translate in a very accurate location. So one myth that probably is worth to clarify upon is that many companies in the market, when they try to do some comparison between Bluetooth and other technology, they tend to only mention about Bluetooth for location. And Bluetooth for location actually has many different flavors. So if a company is saying I'm using Bluetooth for RTLS, well, the next question should be which one? Because historically, Bluetooth with the beaconing technology, as an example, has been used, as is shown here on the left-hand side, effectively leverage on the RSSI methodology. So by measuring the power of the signal and ergo from that deriving the location of the object. This is the standard BLE methodology being adopted and used since 2010. But with the introduction of Bluetooth direction finding and with company like Quuppa being able to provide an entire platform based on direction finding, we are able to take a Bluetooth signal and translate it not to a proximity information, but to a very accurate location. So again, if someone is asking you, I'm using Bluetooth, you should really ask to them which one, because as you can see, there are very many differences in terms of accuracy, precision, and latency. And if you want to read more, there are here some links to some articles. This table is something that compares or tries to compare our technology with others. I realize that this is probably going to trigger a lot of questions, and we are happy to answer any question might come in. This is a comparison done in light of a network-centric architecture. So that means using, for instance, the case of Bluetooth direction finding AOA. And in this case, you can see that the Bluetooth direction finding can be actually very, very accurate and performing, and at the same time meet a very good total cost of ownership. So that's why our technology has been effectively the technology of choice by many companies, even coming in after having tested and tried other methodologies. One of the things that we can do very well is scale. And we have many projects that are very, very large with many deployments, many buildings, many floors. And also our technology can run both in a Bluetooth compatible mode as well as on a proprietary mode. And in this way, we do not have problem with security or other problem related to, for instance, spoofing and so. So there are different flavors that the Quuppa technology can be readapted to operate, and we'll be happy to answer to some of these questions in case they come in. The key benefits of our platform is that our platform is really built for scalability, and since the beginning we have been doing this. So we have built a platform that is accurate, so we can go down if needed to 10 centimeter accuracy with like 150 millisecond latency. That's what we do in sport. There is plenty of video in the net showing our real-time location performance, but typically that might not be needed if you, for instance, want to track a pallet in a warehouse, or you want to, track a object in a factory. So typically our deployment targets are sub-meter accuracy, but of course, if needed, we can do even the 10 centimeters or the centimeter level accuracy. We are versatile, so our technology can operate both with dedicated tags or mobile phone. And since we have no vendor lock, we can also use the tags from third-party companies, or we allow the open API so that the company can build their own application, software application. It's scalable. So just to give you an example, we have deployments where we cover 45 buildings, multi-floor, multi-level, in pretty much the single project. And now this project is scaling up to more than 90 buildings. So we are not concerned about scalability, and the platform is really built for that. Everyone can make the technology run in a lab, in a small deployment, but very few companies can truly scale. And then it's open because as I mentioned, the idea of not having a lock, but actually having both hardware and software interface available. This is a slide that we could spend a lot of time discussing, but for the lack of time, I just want to highlight a couple of things. So the Quuppa platform, also in the sake of scalability, it's really built for having a convergence of use case, which means having one infrastructure piece that is able to run many and multiple use cases all at the same time. And in order to do that, the system needs to be able to provide different level of services to the devices that are connected. So our infrastructure, the locators, as well as our software, is able to operate both in a network-centric or in a mobile-centric architecture all at the same time. And that's how we are able to both effectively do RTLS or asset tracking, as well at the same time potentially provide the data for mobile-centric positioning. We can do both the RSSI, the proximity, if some customer wants to do that, or we can enable that. But our target is really to do the high accuracy positioning with direction finding. Key features of the platform, I'm not going to go through all of them, but I have already touched upon a few. But as you can see, all of these key features, they are really built with the idea of scalability in mind. And the idea that you need to have a platform that is able to really satisfy many different use cases and needs from the end customers. On the market, there are many platforms and technologies that are good at solving one or two problems. They are very optimized for that. But when you really talk about scalability into, for instance, a building like for smart spaces, there are many stakeholders, facility manager, the landlord, the tenant, and all of these stakeholders, they have different use cases. And you want to provide to them not a silo solution that only can satisfy a few of them, but really a platform that could be horizontal in terms of satisfy any needs. And that's practically how our platform is built from day one. And of course, total cost of ownership is a key important step into that. So of course it's important to deploy the system, but then you have to have something that can be remotely maintained, having telemetry, and effectively keeping down the running cost. We are a horizontal technology provider, and as such, we don't focus into any specific vertical market. That's what we do through our partners. So our partners are our channels to the market, and we have partners that are operating across these vertical markets here described. That for every vertical market, as you can see, there are many use cases. Our platform stays pretty much always the same. It's just a matter of configuration or planning for deployment, but otherwise it's very flexible and can be readapted to track a pack in an ice rink traveling at 40 meters per second, as well as tracking a pallet that is sitting on a rack in a warehouse, and everything in between. The platform it's flexible in this respect, also in terms of how do you target for accuracy. So there are technology in the market like ultra wideband that are typically very good at providing high accuracy, but they start to have limitation if, for instance, your customer needs to downscale the accuracy in some area of the deployment. Because when you have, again, massive deployment, you might not need the 10 centimeter accuracy everywhere, but you might have an area that requires higher accuracy, area that requires lower accuracy. So our platform is built to be able to satisfy all the spectrum of needs. So we can go down to the centimeter level accuracy if needed. That's what we call the positioning. In other area or in other project, only proximity might be actually good enough. And then in some area where you do like inventory management or auditing for warehouse goods, then even presence detection might be good. So there is an article on our webpage where we describe this. And of course, all of these three different deployment examples, they really translate to real use cases and project. And within the same project, the customer can tune the Quuppa system to really provide the level of accuracy that is needed. This is very important because it optimizes the overall cost at the end. The Quuppa system is also easy in the sense that you can think it like putting lights. So if you don't want shadow, then you go all the way to position, you put a lot of lights and you cover everything, but then the system becomes highly accurate and reliable. Otherwise, if you are okay to have some area with shadows, but you want some spotlight and with high visibility, you put the lights to illuminate those areas. So the analogy is pretty straightforward. We have a partner ecosystem, which effectively embraces different type of partners. And we would be happy to discuss more with you. The tag partner is what Santo is soon going to describe. And this is a slide that shows our global footprint with our offices spread around the globe, as well as what are the type of partners that we are typically working with. And now, without further ado, I'm just giving the floor to my colleague Santo, that is briefly going to tell us more about tags.
All right, thank you, Fabio. I'll try to be very brief here since we have a lot of slides left and then not so much time. So I think it's fair to say that all of the use cases require slightly different tag. You can imagine that forklift and the people being in the exercising in the gym would not use the same type of tag. And as Quuppa, we are not even trying to be the company who is creating all tags for all these use cases, and therefore we're building tag ecosystem with great partners that we have, and we're expanding those all the time. Next slide here. All right, so a couple words about the tag ecosystem. So the main benefits of being in Quuppa's tag ecosystem is that the tag partners, they get access to our ecosystem companies and the partners that we have there. There are a lot of large and small companies from very different industries, and we as Quuppa, we facilitate the sort of partner acquisitions for our tag partners, and we try to handshake the companies to work with each others. For tag vendors, being in part of the ecosystem obviously means new revenue streams. And as Fabio mentioned, these RTLS use cases can really scale up to 6 figures. And by 6 figures, I'm not meaning the dollars. It can be dollars can mean much bigger amounts, but even the use case itself can be up to hundreds of thousands of tags if we talk about large warehouses and so forth. For tag vendor, we try to make it as easy as possible to build Quuppa native tags, and therefore we have created Quuppa. I see a little typo here, but we have built a firmware library for nRF52A32 radio, and this means that the implementation of Quuppa native tag is actually in the matter of days or weeks rather than months. We do a lot of joint marketing with our tag partners. We list them on the website. We do joint webinars. We do exhibitions together, joint PR, and include the partners in the newsletters and so forth. There's here really the partners and the imagination is the limitation what we can do together. We're very open to do all the new stuff with you guys. I wanted to include here a couple of very kind of hot topics from this year. Obviously, since the COVID-19 became the main news for our daily life, the requests of the bracelets and the wearables have really exploded. And therefore, we have been asked almost on daily basis if you have a wearable this and this type that can, for example, vibrate and the sort of alert the people so that if they're, for example, too close to another person, so to keep the distancing. Highly visible LEDs has been kind of a constant request as well. Barometers to track the elevation of the assets, ATEX tags or any other type of certifications, and accelerometer and gyroscopes has been also requested. Eligibility of how to become a tag partner. So basically what we are seeking, we rather work with companies who are established and who really seek to expand their business. Companies can be startups or new companies as well, but we rather want to see the companies are up and running when we start collaborating. We expect that the company who's working on the tax side with us has know-how and experience in embedded development, electronics engineering, and antenna design. Antenna design being one of the most important ones. Of course, you can outsource this expertise, but it's very important the antenna is well designed with the asset tracking tag. Typical background of the company working with tags with us has experience in BLE sensor devices, typically beacons. Beacon is not the tag that we like to say. The tag has a nature of moving. Tag is moving device, while beacon is typically stationary. So we like to emphasize this thing. Partner has to be able to support their customer and control the quality, and it's very important that the tag vendor seeks from the very beginning to specialize on something, either certification, specific market area, or for example, some form factor. We have a lot of already companies who are building tags that are affordable. There's nothing wrong with that, but if you try to specialize a little bit, it helps you to gain more business. So I'm trying to go this very briefly. So currently we have native compatibility on nRF52A32. We're extending the support this month. This quarter in form of closed beta to 833 and 840, seeking those to be available publicly in Q3, and there we are also expanding the support for 811 and 810, and those are expected to be available by the end of this year. Currently, we are, as you see, we have been building stuff on 52 family, but for the future Nordic semiconductor Bluetooth radios, we are working to make Quuppa direction finding profile to be easily integrated with the Nordic NRF Connect SDK. Here I'm not going to, don't worry, I'm not going to read these things, but since you will be given the slides later on, you can see what the firmware actually includes, what features. When I'm talking about fast track and fast development and smart features that get the native support from the Quuppa system, these are some of those things that it means. And I think that's it from my part.
All right, thank you, Santu. So next we are going to give the floor to Thomas, and he's going to take us through some of the more commercial parts. But maybe before going there, Petter, do you think that you can play shortly the ice hockey video? Just to give an idea to the people that when we were talking about down to 10 centimeter accuracy, that was actually for real.
Yeah, I'll try to see if I can get the video up and running.
Should I stop sharing?
Oh, it's fine. Just keep it there.
Okay.
Okay, so yes, so that's Thomas here. Hi. Yeah, so that's just an example of one of our sexier partner applications. You might call it Bitwise, who's been successful in winning the Finnish and the Russian Premier Leagues last year, and are on the roll of adding more leagues this season, but more to come on that one. But yeah, the video is of course a marketing video, but it tells you a bit about what you can achieve with Quuppa's RTLS technology. I just want to spend just a few slides on typical use cases that our partners are engaged with today, and the most traditional ones are in the asset tracking space. This is what we have been probably to 85–90% of the cases are related to tracking assets. To some degree, or actually to a large degree, down to the privacy matters that goes with tracking people. It's less acceptable in many markets, in many regions. But tracking an asset or a box or a pallet is fine wherever you go in the world. This slide is just trying to list some of the key industries where high accuracy positioning or tracking is deployed today by our partners. The most common industry is industrial IoT, or more specifically in manufacturing and logistics, where you typically have spaces like you see here on the picture, where it's big open spaces, randomly placed objects or assets, all looking the same, but are actually not. There's different composition in the material, and it makes it very, very cumbersome and time consuming for example, for the forklift driver to fill a shipment that is due to leave. So by having each of these pallets tracked, having the guidance for the forklift driver to pick up the goods improves the process efficiency, or improves the pickup process immensely. As Fabio mentioned, some of our partners are using our system also for inventory management purpose. So really being able to tell how many pallets are in this warehouse simply by sniffing for the MAC IDs of the Bluetooth tags that are attached to the pallets. And in some industries, we do already use people, or they are tracking people as well, especially when it comes to the safety of the workers. Collision avoidance of forklifts and workers is a typical example of that. Then on the construction side, that's becoming a hot topic, not only for efficiency purposes, really knowing where the different assets are, because typically we talk about pretty expensive tools, but it's also the time that is actually spent trying to find a tool. And unfortunately, in many markets, there's a risk that the tools just suddenly disappear from the sites. So having a tagged tools is something that constructions finds very beneficial. One of the emerging ones, especially now with the COVID situation, is in healthcare. Knowing especially where mobile equipment is, and typically this sort of equipment is not cheap. So some of the hospitals that are using Quuppa is seeing an extremely quick return on investments simply by not having to buy yet another something that is costing you then 10,000 euros for a portable or mobile scanning device, for example. Then on the maintenance side, all of you who have been into for example, airplane hangars knows the sheer size of this spaces. And if you can digitalize the work order process by having the work orders displayed on the workers' smartphones or tablets, telling them where they can find the tools and the parts that are to be used for the job at hand, you can not only increase the efficiency, but you can also ensure that the quality of the task is being performed correctly, using the right type of tools and the right type of spare parts, for example. And then in the retail space, there is an increased demand now, especially with COVID and the fact that people are more ordering online, and in markets like US, the click and collect process is becoming very, very popular, meaning that you order and then you pick up it from the pickup place. The back-end process within the retail stores are struggling, and hence they need to know better where the products are that are being ordered, and hence tagging those is something that starts to be a use case that is increasing in demand. Anti-theft solutions, something also, of course, that more valuable goods, starting from PlayStation devices to very expensive handbags, for example. If you can avoid them from disappearing from the store without being paid, that of course is a huge cost saving for the businesses. Then on the more interesting areas, so the ones that have actually since early this year started to pick up in pace, are really the people tracking type of use cases, and I'll call them must-haves, because in many industries it is a must-have. You have to be able to ensure the safety of the worker, for example, in an oil refinery. You have to ensure the safety of a nurse or a doctor in a rehab center or hospital, and there are many different ways how our technology together with our partner software can help ensure the safety of these workers. There are highly secure in places where the access control systems aren't adequate that are there today. You see people tailgating each other through gates, and by combining, for example, Quuppa technology with some advanced LiDAR type of systems, you can ensure that there is only people allowed in or identified that are allowed to be in the space that can be achieved. And then you have elderly care markets where there are very costly consequences if the dementia patients are, for example, wandering away or eloping, as it's called. And if you can have a technology in place that is less intrusive than video cameras, but more powerful than that, then it's something that some of our partners are seeing as the technology of choice for that industry. Law enforcement is, I don't know how many hundreds of police stations and prisons there are in the world that are Quuppa powered today. It's typically not an industry we talk widely about, but it's still a fact that there are needs to ensure the safety of not only the staff members, but also the inmates, and there Quuppa is one of the used technologies. And more lately, we've seen in the US, several states are enforcing means to ensure the safety of the staff in hotels. So the cleaning and room service staff members need to be able to alert that there is something fishy going on and get assistance if needed. Then on the COVID-19 implications, here are a few examples of where Quuppa is used. The one on the right is what NESA Solutions in the US is using, especially in the healthcare sector, but also more widely. So it's really identifying where people are getting too close to each other for too long, and that way you can actually indicate and record the contact tracing and trace back to the source of the virus. In the middle, you have our Middle Eastern partner, Restrata, who is using our technology for managing the people who should be in quarantine and having bracelets that they've been given on the airport and then taking to the quarantine place, and then using Quuppa for ensuring that the trigger is alarmed if they are leaving the space before the time is due. Of course, might sound very harsh, but that's the rules that apply in many markets today, and that way we've been able to actually fight the virus also more efficiently. And social distancing, there are several of our smart building partners, but this is an example of the one from HB Reavis, who is expanding its smart office offering to also fight the virus by having social distancing information recorded, by being able to indicate where there are clean spaces, clean desks, cleaned workstations, and being able to notify the employees who might have got exposed to the virus. And then lastly, the hand hygiene, which is a killer, to be honest. In hospitals, too many patients are being affected or infected by the hospital virus, and if you can ensure that hand hygiene rules are being followed by the staff members, you can have a huge impact on the number of cases. And here we are using our highly accurate tracking technology with the sensing devices in the sanitation stations. We are applying geofence areas not only around the sanitation station, but also around the patient beds, and can hence trigger a notification for the staff member who is actually neglecting the compliance rules of hand hygiene to remind him or her that you have to actually go and wash your hands before attending the next patient. We have a couple of case studies on our website. This is one from Japan, where they're seeing huge improvements in the compliance simply by using this technology for their staff members. Okay, so that's from my side. Thank you very much. Over to you, Fabio.
Thank you, Thomas. So this is just a very quick summary about what we've been discussing so far. So we would be more than happy to take any question that you're going to have in the last part of this webinar. And then depending on which business you are in and what you are more interested to potentially do with us, please follow up with Quuppa. If you are a TAG partner and you would like to join our TAG ecosystem program, just go to our webpage and you can fill in the form. If you are a value-added reseller, system integrator, or solution provider, then you can also contact us directly, and we will be happy to discuss offline and understand how we could work together. And also, if you are an end customer and you would like to understand better how a Quuppa technology used as an enabler within your building could help to embrace a large variety of use cases, So we'd be happy to provide you some consultation and to discuss about your need and potentially to put you in contact with some of our partners in the ecosystem, and then they could address your need. But without any further ado, I think that at this stage we want to thank you a lot for having been online and listened to this. And Petter, we also would like to thank Nordic for the opportunity, and we are ready to take any questions if there are any.
Thank you, Fabio, and thank you guys for that great presentation. We have quite a few questions here. I can take the first one. Is this presentation available somewhere so that we can easily follow the referenced links? The answer is yes. I will share the presentation and a recording of this webinar probably tomorrow, and we will send out an email to everyone where they can find this. Then next question is, can the firmware libraries be integrated to a custom nRF52840 design, say using the Fanstel BT840F?
Okay, I think that might be for me. Can you guys hear me?
Yeah, I can hear you.
Cool. So currently we have the Quuppa Native firmware library available for nRF 52832, but it will be also available for 840 during Q3. And as far as I know, the Fanstel BT840 is a module, and yes, you can use modules. But what I think it's important to emphasize here is that you choose the one with the as omnidirectional antenna as possible, something high quality. We typically recommend to use printed IFA antenna. It's important that it doesn't have any deep nulls when you do the antenna measurements.
Thank you, Santtu. The next question is, what is your technology of Bluetooth for RTLS? Did you use Bluetooth 5.1, angle of arrival, angle of departure solution? What is the license policy and the business model to the customer?
All right, Peter, so I will take the first part of the answer, and then I will let Thomas to fill in on the commercial side. So our technology can be made compatible with Bluetooth, and or it can operate on proprietary mode. When we operate on the Bluetooth mode, you don't need to have tags that are 5.1 compatible, but you can effectively take any device that is Bluetooth 4.0 or beyond, and by modifying the structure of the Bluetooth low energy advertising packet, effectively turn that device to become Quuppa trackable. So as most of you might know, the BT-SIG, AOA and AOD, they don't have yet the profiles that have been frozen, so they're still under discussion. And the Quuppa instead offers the profiles already today. So our profiles are practically extensions upon the standard, similar to what iBeacon and, for instance, Eddystone are extension to the standard BLE advertising packet. And then for the commercial part, Thomas, I leave you the floor.
Sure, thanks. Yeah, the locator hardware itself comes with a hardware price, and which we then sell to our partners for reselling it to their end customers. And then on the software side, each locator comes with a subscription fee, and subscription fee size is also a bit dependent on the performance of the system required. So for hockey, for example, where the latency requirements are extremely stringent, and also the location update rates that needs to be supported, that is a higher fee compared to, for example, a subscription where you only need to track, for example, the shoppers in a retail store. But they are all subscriptions are tied to the locator hardware, not to the number of tags tracked.
Thank you, Fabio and Thomas. Next question is Is it possible for a device to alternatively broadcast data on standard BLE channels and on Quuppa proprietary channels? The use case is to have precise localization in the area covered by Quuppa locators, but also presence detections of assets stored outside with a standard smartphone.
That's a great question, and the short answer is yes, it is possible. So we already have today deployments where tags can be configured to transmit on the BLE standard advertising channels, for instance, broadcasting standard iBeacon or iDistant packets, and then at the same time send out alternatively radio packets that can be picked up by Quuppa on the proprietary channels. So there is a lot of flexibility on how devices can be configured and on how our platform can pick up the signal. But if you want to know more, please don't hesitate to contact us, and we'll be happy to have a discussion offline.
Thank you, Fabio. Next one is, I am a potential end user of Quuppa solution in the industrial market. I found it very difficult to find a reliable and non-biased information about the Quuppa system. We absolutely want to avoid any vendor lock-in with a Quuppa partner. How can we avoid that?
This is another very good question, and so we have an open platform where once we provide the API, the applications or the tags can be freely fetched and provided by different partners. So we do have deployments where effectively the end customer is owning the infrastructure, and then they can freely decide which system integrator or solution provider will get access to those data and be provided a solution in return, or they can go into the market and buy Quuppa approved devices that will be plug and play with their platforms. For us, avoiding hardware lock is a very important thing. We take it seriously, and we'll be very happy to discuss with this person more offline, and to also provide him some reference that hopefully will be less biased than the one he has seen so far.
Thank you. Next one is, I'm a consultant for a small factory of BLE devices based on Nordic SoC. How can we make our devices Quuppa compatible?
All right. I think the same as the previous one. I think it would be best if we talk one-on-one separately. But what you can do first is just to check out our website for the ecosystem, and then see what you find from there, and just either send me email santtu.pulli@quuppa.com, and or you can just leave the contact form from the website if you find it from there. Let's take it from there.
Thank you, Santtu. Next one is, there is very limited and vague information on Nordic DevZone about how to make a Quuppa tag. Is there any chance that this will change in the future? An example available in the SDK package would be awesome.
Okay, another great question. So as mentioned many times before, currently we support the 832, and soon we will extend the support for 833 and 840. But for the future Nordic Semiconductor Bluetooth radios, we are working for making the Quuppa direction finding profile to be easily integrated with the Nordic NRF Connect SDK. So I think that will be something that we all look forward to see in the future.
I agree. Next one is, what is the range supported by BLE, max distance between tag and receiver?
Yeah, good question. So the first thing to clarify is that Bluetooth is typically thought as a short-range communication technology with a range that is up to 10 meters. But that is true only in the case in which you are transmitting one megabits per second. So in the case of Quuppa, and when you use the Bluetooth technology for location, the bit rate is significantly less, and in return you get much more range. So the communication range between the tag and the locator, like the indoor locator, the Q17, it's roughly around 100 meters, and between the tag and the outdoor locator is about 300 meters. So this is for the communication range. For the coverage area per locator, that depends on the mounting, on the ceiling height, and on how the locator inclination is. Just to give some number, if you go to an industrial site where the ceiling height is about 10 meters, one locator is already covering between 300 and 500 square meter. And then as the ceiling height increases, we can cover up to 1,500 square meter. So it really depends a lot on the environment. But if you want to read more, we have an article on our webpage which talks about coverage versus range, and that might be something where you can find some more information. Otherwise, please contact us and we can talk more.
Thank you, Fabio. Next one. Would your sensors provide location as well as sensor data, heart rate, temperature, gyroscopic, etc., simultaneously? Also, is there any audio layer on them?
Okay, another fantastic question. So yes, the tag can actually can be configured to expose the direction finding radio packets as well as the data packets that contains the sensor data. And in the end, it's up to the what functionality stack will entail. It's up to developer what they want to build. There is an uplink and downlink spec to do all those use cases.
Thank you. The next one is, does the software QPE support installation in the cloud? What are the requirements for the cloud? If the cloud's computing power is strong enough, then the Quuppa positioning engine can support an unlimited number of locators?
So good question, and this one really falls into the scalability part. So our Quuppa positioning engine can run either on the cloud or on premises. It's typically up to the system integrators and solution provider to decide how to architecture the solution for the end customer. From a robustness and reliability perspective, mainly to avoid data loss between the communication on-premise to the cloud, Quuppa is typically recommending to run the system on-prem and instead having the application layer running on the cloud, so that the Quuppa positioning engine effectively is a controller which receives the data from the locator, translate those raw data into location information and send that into the cloud. So there is a lot of flexibility on how the system is architecture, and again, it's really up to design to agree with the end customer what is the best architecture.
Thank you, Fabio. Then we have the last question, I think. Is the antenna array in the ceiling receivers a Quuppa design? Is this part of the Bluetooth low energy spec, or is it defined by the SoC vendor?
So the antenna array is defined by Quuppa and is part of the Quuppa design. So it's part of our IP and our expertise on how you build the antenna array to be able to optimize the performance of the positioning system. The antenna array is not defined in the BTSIG, by the BTSIG as part of the standardization. They provide a reference design, but that one is typically used for very simple tests. If you effectively want to build a system which is reliable and robust in harsh environment, then the design of the antenna array is very important. And it's not neither part of what the silicon vendor provide. We have silicon vendor like our partner Nordic, that they have their own design on the antenna array, but those are different than the one that Quuppa uses in our own platform.
Yep. Thank you, Fabio. First one is how many devices can be installed in a warehouse for asset tracking before network congestion occurs? What is the maximum range between one tag and one locator?
Yeah, that's a great question. So let me break it down in parts, the answer. So let's start with the range. So the communication range between a tag and a locator for the indoor locator is 110 meters, and for the outdoor locator is 300 meters. This is a myth that needs to be also killed in a way, because typically people think of Bluetooth only for short range and communication, but that's true if you are transmitting a 1 megabit per second. Since in this case, between the tag and the locator, the transmit rate is actually significantly lower, therefore the communication range is significantly longer than the nominal 10 meters. So we have installation in warehouses and even in airplane hangar where the ceiling height is like 40 meters, and we have no problem to track the assets underneath. And even having deployment outdoor where the locator are mounting on light poles, we can track the objects that are moving in an open area. When it comes to the density of the locators, there is no limit, because unlike Wi-Fi, where if you put too many infrastructure pieces, you start to suffer from co-channel interference, in the case of the locator, they are mainly receivers. So the density of the locator really depends on the accuracy and reliability that the use case would require. To give you some example, in an industrial set where the ceiling heights start to be from 10 meters and above, already at 10 meters, one locator would cover 300 to 500 square meters. And then as you get higher with the ceiling, then the footprint increases. And we have deployments where single locator covers more than 1,000 square meters. So it really depends on the environment. But this is something that if you have a project, if you are a system integrator, please contact us and we can take your case and discuss more in detail.
Thank you, Fabio. So then next question is, do special conditions have to be met for antenna in the transmitter? How can a signal reception range be increased?
Yeah, so this is somehow linked to what I discussed before, but effectively on the tag side, there are a few design criteria that or best practice that we can happily share with you, but there is no any special design of the antenna on the tag. So typically we would recommend that the tag should have an antenna that is as omni as possible. So it's not a matter of matching or efficiency of the antenna. Typically, the link budget is more than enough to be able to receive the data. What is important is that the tag make itself visible to the infrastructure, to the locators. That's why having an omni antenna would be recommended. Clearly, in some cases, there are design constraints, but that's where we are happy to take this question offline and to give you some example. And remember that we don't use power for computing where the signal comes from, but we measure with our locators that our antenna raise directly the phase of the signal. That's why it's not really important what is the RSSI.
Thanks, Fabio. Then there's a short one. What is the accuracy?
Well, the accuracy, we can go down to really centimeter level. So if you look at our webpage, you might find a video, what we call the table hockey, where with only one locator, we are able to get literally centimeter level accuracy. That's like a miniaturized deployment. When we talk about real scale deployment in facilities, then 10 centimeter is typically what we aim when we really squeeze the performance of the system. And as said, we do that across, for instance, more than 50 arenas in sport. We also do accuracy of like sub-meter, like half meter, even 30 centimeter in retail and in warehouses. but it really depends on what is the constraint, because the more accuracy typically means more infrastructure, so the cost goes high. So that's why it's always a trade-off between what the end customer need is and what the Quuppa infrastructure needs would be in order to meet that need. But that's why having a flexible infrastructure like ours really helps to tune that cost and find the right trade-off.
Thanks. How do you define real time? In your slide, you mentioned that RSSI is not real time.
That's a great question. So real time is always a relative measure. So we have customer that for them real time is 5 minutes. Everything that is less than 5 minutes is real time. But if you do sport, 300 millisecond or more than 300 millisecond is yesterday. It's too late. So as such, when we talk about real time, we are typically talking about less than a second or around a second of latency. So these are the use cases that we find in for instance, navigation or wayfinding, or if you need to trigger a notification for security or an hazard area, typically a second start to be on an acceptable level. In sport, we go all the way to 150 milliseconds. And then we have other deployments in industrial where even 20 seconds, it's okay for them. The reason why we say that RSSI is not real time is that typically you need to do a long average in order to mitigate the variation of power, the fluctuation of power, and that typically introduces 10 seconds or more latency. That's why we say that is not real time. But again, everything is relative. But good question.
Thanks, Fabio. Why use Bluetooth for localization? My understanding is that Bluetooth was made for communication between devices and suffers from interference. What makes it powerful for localization?
Thanks for the question. This is another good one. So Bluetooth is absolutely true. It was originally made for communication, and later on it was readopted for the beaconing, the location RSSI-based beaconing. But that's why when you talk about Bluetooth for location, the question is which one are you talking about? Because Bluetooth direction finding was actually created for location from the start. So Bluetooth direction finding, it's not a methodology and technology thought for communication, but it was architecture and thought to be able to cope with some of the physics of the location in problem. And multipath is dictated by physics. So it's something that any radio technology needs to face. And the Bluetooth direction finding, it's built in a way that could be made robust against multipath. So we know about some arguments that other technology provider not using Bluetooth, but using wide spectrum signal claim against Bluetooth that Bluetooth is narrowband, therefore they cannot solve multipath. Well, that's unfortunately is not true, because while, for instance, ultra wideband can resolve multipath in time because they have a lot of bandwidth to spare, well, in the case of Bluetooth direction finding, we solve multipath in space, which is another dimension. But we can do very similarly, and that's why we have no shame to be able to provide the same performance as ultra wideband, even in harsh environment. And if you want to see some example of those, we have case studies on our webpage where we track objects in steel manufacturing factories or in car production lines, and trust me, there is a lot of metal there.
Thanks, Fabio. On slide 4, it was mentioned that Quuppa doesn't make silicon, implying all BLE devices can work with Quuppa. However, on page 5, we see the term Quuppa compliant BLE tags. Can Quuppa track all smartphones with Bluetooth 5.1 chips with the same accuracy?
Yeah, good question. So actually, the good news is that you don't even need to be 5.1 compliant chip in order for Quuppa to track. So any device, any phone or tablet or computer that has Bluetooth 4.0 or above, effectively any device that can send a BLE advertising packet. Just by changing the payload of the advertising packet, we can track that packet. That's what we call the Quuppa profile. So in fact, Quuppa has two different operation modes. We can operate in a proprietary mode, or we can operate compatible with the standard BTSig. But remember that at the moment there is not yet profiles in the Bluetooth direction finding. That's why we are working together with Nordic and with other silicon vendors to be able to provide into the market a profile that could already be leveraged today in order to exploit the Bluetooth direction finding capabilities.
Thank you, Fabio. So next question is, how well does this perform when not having a direct line of sight with locator and tag?
Yeah, that's so. As I already touched in some of my previous answers, so the Quuppa system, it's based in its core logic, and that's really a function of the Quuppa positioning engine to be able to mitigate multipath. So we can solve multipath and reflection not in time because we have a narrowband signal, but we solve it in space. And by doing that, we can cope quite well also in multipath and harsh condition. The tag does not need to be always in line of sight. We can also cope with no line of sight situation. Then it becomes important to do the planning. So that means where you put the locator within the facility. And to help in this task, we have built a software application tools that we call the site planner. We call it the Quuppa system simulator. We call it the Quuppa data players. And all of these tools are essential for helping our partner and customers to make the best assessment when the technology is deployed so that they will know where to put the locators even before doing the physical installation. But it's something that is very easy to do. The tools have been simplified to the level that you don't need a PhD in radio engineering to be able to deploy the system. And again, please have a look on our case studies on our webpage. All of those are real successful projects where we are able to reliably track with sub-meter in harsh environment. Sorry about that.
Thank you, Fabio. That's then we're out of time, I think, because it's over 10. So I just would like to give a big thanks to Quuppa and Fabio, Santu, and Thomas, and everyone listening in. I hope you enjoyed the webinar. And if you have more questions or your question didn't get answered, you know that you can go to DevZone or contact Quuppa directly, and we will help you out. And I will make this recording of this webinar available at webinars.nordicsemi.com together with the presentation. And yeah, I think that's it.
Thank you. Thank you very much.
Thank you.
Thank you. Bye.
Take care. Bye-bye.